Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing statistics and mathematics at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school level and college level. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. All right. So the first question is asking us to determine the derivative of secant 2x to the exponent of 3 minus secant 3 times secant 2x. Okay. Okay, so let's copy down the question first. Okay. So what is the derivative of secant 2x to the exponent of 3 minus 3 secant 2x? Okay. So before jumping to this question, there are a few things that we'll like to first introduce. Okay. So the first thing is a difference rule for derivatives, which is given by d dx. And we have two functions, which are fx and gx, and we do the subtracting of them, and this is going to be equal to d dx fx minus d dx gx, right? So that's sort of like a difference rule for derivatives. And the second thing I want to mention is a chain rule. Right, so for say we got fx is equal to 2x plus 1 to the exponent of 2, and if we want to take the derivative of it, it's going to be derivative of fx is equal to move 2 to the front, and so the exponent 2 will becomes to 1, and always remember to times the 2, because 2 is a derivative of this part. Right. So this is take the derivative of 2x plus 1. Right. And the third thing I want to mention is the identity of trigonometry. One of the identities of trigonometry, which is given by 1 is equal to secant 2x squared minus tangent 2x squared. And we can always play it around. So this is also be equal to 1 plus tangent squared 2x is equal to secant squared 2x. Alright, so by knowing these three, let's go back to our question. Okay. So let me copy down. Okay. So we got secant to the exponent of 3, 2x minus 3, secant 2x. Since we want to get the derivative of the difference between the two functions, we need to apply the difference rule for derivative, which we just stated earlier. And so we state that the difference of the derivative of the difference of the two functions is equal to the difference of their derivatives. Right. So I'll rewrite the difference rule again. So d dx fx minus gx is equal to the derivative of fx minus the derivative of gx. So now we just need to substituting the fx and the gx back. So I'll change the color. So sub fx is equal to secant 2x, gx is equal to 3 secant 2x. Right. So now we have d dx secant 2x to the exponent of 3 minus 3 secant 2x. And according to the difference rule, this is also equal to derivative of secant 2x to the exponent of 3 minus derivative of 3 secant 2x. Right. So now, first let's evaluate the value for derivative of secant 2x to the exponent of 3. Okay. So evaluate derivative of secant 2x to the exponent of 3. And here we need to use the chain rule. Chain rule apply. All right. So we have derivative secant 2x to the exponent of 3, and this is going to be equal to, we take the 3 to the front, so 3 secant 2x to the exponent of 2, because 3 minus 1 is equal to 2, and we also need to do the chain rule part, which is the derivative of secant 2x. So coming up, we keep the first part the same, so 3 secant 2x squared, and the derivative of secant 2x is going to be equal to secant 2x tangent 2x, and we need to apply the derivative rule again. I mean the chain rule again. So derivative of 2x. Yeah, so for this part. So now let's copy down the 3 secant 2x squared times secant 2x tangent 2x, and the derivative of 2x is just going to be equal to 2. So simplifying further, we will have our answer for this part, which is equal to 6 times secant 2x to the exponent of 3 times tangent 2x. Yep. So we apply the chain rule again, and now we need to evaluate for the second part, which is a derivative for 3 secant 2x. Okay. So evaluate derivative of 3 secant 2x. Chain rule applied. Chain rule applied. All right. So let's copy down the question. derivative of 3 secant 2x. So this is going to be equal to 3 times secant 2x tangent 2x times the derivative of 2x, which is from the chain rule part. And then this is also equal to 3 times secant 2x tangent 2x, and derivative of 2x is just going to be 2. So by simplifying this, we will get 6 times secant 2x tangent 2x. Right. And so now we got the both part, so we can calculate the difference of the derivative of secant 2x to the exponent of 3 and 3 secant 2x. So we will have, so now we calculate the difference of the first part and the second part. Right. So we will have derivative of secant 3 2x minus 3 secant 2x is equal to derivative of secant 2x to the exponent of 3 minus derivative of 3 secant 2x. Right. And so this is also equal to 6 secant 2x to the exponent of 3 times tangent 2x minus 6 times secant 2x tangent 2x. And so the first part comes from here, and our second part comes from here. And we just need to do the subtracting. Right. So now we can do the calculation. So we take the common factor. So it will become to 6 secant 2x tangent 2x times secant 2x squared minus 1. Yep. So this part looks fine, but this part we can actually convert this to some other things. And recall, at the beginning of this question, I mentioned about the identity of trigonometry, which is right here. Right. So now we see we got a secant 2x squared minus 1. And here we can actually get tangent 2x squared is equal to secant 2x squared minus 1. So we can actually subbing this in, and we will get, let me write this down here. So by using the identity, 1 is equal to secant 2x minus tangent 2x to the exponent of 2, we will have 6 secant 2x tangent 2x times tangent 2x to the exponent of 2, and remember these two are exactly the same thing. Yeah, the two gray part, right. So now let's keep doing the calculation. Since we got a tangent 2x to the exponent of 2, and here's a tangent 2x to the exponent of 1, so we can combine them together. Thus we have 6 secant 2x times tangent 2x to the exponent of 3. And now let's just rewrite it again. So that's also be equal to 6 tangent 2x to the exponent of 3 times secant 2x. Right. So that's our final answer. Right. So let's write down the conclusion. Therefore, the derivative of the function secant 2x to the exponent of 3 minus 3 secant 2x is 6 tangent to the 2x to the exponent of 3 times secant 2x. Yeah. You can also write it as 6 secant 2x times tangent 2x to the exponent of 3. They're exactly the same thing. Yep. So I think that's all we got for this question. Yeah, so it's a quite long question. So maybe I'll just summarize a bit. So the key point of solving this question is you need to remember these 3 rules, which are the difference rule of derivative. So we just need to get rid of the bracket and just take the derivative of each function and do the subtracting between them. And also the chain rule. Yeah, don't forget to take the derivative of whatever is in the bracket. And also the identity of trig. So 1 is equal to secant 2x squared minus tangent 2x to the exponent of 2. Yeah, and you can always move things to the right hand side or to the left hand side. Yeah. So I think that's all we got for this question, and let's leave a comment there. Right.